Okay, echo is weird, but okay, echo is weird, but okay, echo is weird, but okay, yeah, I figured it out. Okay, yeah, I figured it out. Okay, yeah. Basically, yeah, it's just having another instance of the stream running in the background was causing echo. But oh yeah, not that much new or notable right now. Kind of right at the edge of the resource limit. That's with two cores on the FPGA, and you know that already pushes it pretty close. And I recently increased the cache size as well, so 88% is with 16 kbytes for the L1 caches on both cores, and having 128 kbytes of L2 cache. Increasing the cache sizes did have a modest improvement for the frame rates in Doom, but not really that much noticeable with either Raw or Quake, which is kind of annoying. And despite my efforts, Raw is still pretty buggy and prone to crash things. But still working on that part. Still kind of buggy in the emulator as well. So it's nothing unique to the, or particularly unique to the FPGA version. So, and also the implementation stage takes a really long time, so yeah, it's kind of annoying. So, yeah, recently I've been at home because of, virus. Well, that's being an issue, and technically don't have a job right now because mostly because of virus related reasons, but at least that means more time to sit around at home and work on stuff. But in my fiddling, I did slightly improve the performance of mem copy. So if it if it has the 128-bit load store operation, which is technically optional, which is why it needs a test for this, then it will check if the if the source and destination register are properly aligned, which is kind of needed because the 128-bit move X instruction requires an 8-byte alignment. So it will, OR them together and make sure none of the low bits are set, and if they are, or if none of the bits are set and it comes back 0, then it will basically branch over to this version. Just noted, copies 32 bytes per loop iteration here, and then if there's anything left, I'll copy it 8 bytes at a time till there's no more 8-byte units left, and then it will, invoke this stuff to do the rest. Initially, it was going to branch over to the return instruction, but then I realized, I have predicated instructions, so I can just predicate the return instruction and then, save a few clock cycles due to not branching. Well, I guess technically the RTSU instruction is a branch, it's just a branch to the link register. That and see if it's visible here. So I also did make a slight change to the way prologues and epilogue sequences work as well, in that I've mostly eliminated the use of push and pop instructions when building in performance mode for the main reason that those instructions cause a few extra interlocks, so run a little bit slower, which has a fairly slight gain in performance, but still is better than nothing. So yeah. Yeah, saving a few cycles due to saving a few interlocks. So yeah. Also some fairly heavy-handed optimizations for trying to, squeeze a little bit more speed out of Quake, which I might show here. So, come on. Okay, so yeah, now if the frame rate drops, it will drop the quality, and if the frame rate drops a lot, then it will start making some more aggressive measures. Yeah, that can be seen there. The frame rate drops like too badly, it'll start reducing the draw distance to try to keep the frame rate from tanking too bad. And it also reduces the quality of the sky and models and so on. Basically a similar trick to what I noticed Rot was using to try to improve frame rates. Sadly, it's still not really enough to get all that usable frame rates at 50 megahertz, but yeah, it's kind of a compromise. So, say over here, it's going reasonably fast, so everything's in full detail, but yeah, it's being a little bit uncooperative, but yeah, it's a little bit dynamic in that it has multiple levels of quality reduction, but yeah. So yeah, this is emulating what it would run at 100 megahertz, which is admittedly a bit faster than what my current FPGA builds are actually doing, so, but if I drop it down to 50, then this is where it kind of really starts looking like crap. This is still sort of an experimental set of optimizations and stuff. So yeah, kind of looks like extra crap now, but this is basically the engine trying, well, as much as it can to try to maintain like semi-usable frame rates at like this clock speed. So and if I go over here, quality starts improving again. If I look back over here, it starts dropping it down to try to keep things going. And yeah. Partial answer here is, well, Quake wasn't meant to run it at a 50 megahertz or on a 50 megahertz processor. So yeah. Yeah, a few parts of it were rewritten in assembler, but as can be noted, my amount of assembler rewrite is far less significant than what the original x86 version used, because my version only really rewrites like a few of the inner loops in assembler and stuff, whereas the original x86 version appeared to have rewritten, well, a fair chunk of the render in assembler. But yeah, I'm mostly still using the C code for the renderer. So yeah, it's kind of, performance is a little bit troublesome when it comes to Quake. But yeah. Ideally, it would be nice if such heavy-handed optimizations weren't necessary, but still work in progress. And does at least get a little bit higher than it was, so sort of an improvement. So other changes recently, it now uses jumbo encodings for loading and storing globals. That was something that it could have done a while ago, but hadn't gotten around to adding the logic into the compiler for that, so now it does it. See if there's anything more of note on here. Oh. This is another one of those functions that's not been rewritten into assembler yet, but this can be seen here. It's still within, well, the top 10 code segments that are using a lot of CPU time, but as can also be observed here, it consists almost entirely of memory moves, or memory load and store operations, which is kind of a recurring problem for performance on this thing. seemingly seemingly I've managed to eliminate most of the instructions which aren't memory moves, but that just leaves endless memory moves to deal with. How exactly the original PC dealt with this stuff, I don't really know, but this code that's, consisting mostly of memory loads and stores is kind of problematic. Yes, the question is if there's anything that could have been done to significantly improve this, but if it were the case that like the same or the same fields were being used multiple times, it could make sense to add a temporary variable to cache them into and then reuse them. But a lot of cases like this, there's not really that much redundancy, so yeah. So there wouldn't be much savings from using a temporary value. So yeah. Yeah, in those cases, my compiler isn't really smart enough to figure that out automatically. But yeah. So yeah, it's basically something known as a strict aliasing optimization, if I remember correctly. So, but yeah, mine doesn't really do any of that. The basic premise being, if you infer that like no other pointers in the same scope modify like the same object, which traditionally is based under the assumption that two different variables of different types would never alias. That means that unless you have multiple variables of the same type that could potentially point to the same object, if there's no two objects of the same type pointing to the same object, then what you can do is you can cache the loaded values from the fields from one of them, and then assume that they're not going to change. But if you do potentially have two pointers to the same object in different fields, and stuff's going on with both of them, then you can't really safely assume that things won't be changed from one object to the other, so you can't cache things. Yeah. But doing optimizations based on that takes or requires some level of cleverness from from a compiler, which mine doesn't really have, so it doesn't do it. Firing up Doom should still work because it didn't really change anything notable. So Doom frame rates are now a little bit better. Granted this is in the emulator rather than on the actual FPGA, but the emulator is at least moderately accurate at predicting what the performance will look like. Can switch it into low detail, and that makes frame rates a little better as well, but you know, I've gotten performance to be fast enough where the low detail isn't really that much necessary anymore. But other than C compiler limitations or something of that along those lines, I've not really figured out exactly what I'm missing as far as performance goes in a lot of this stuff. I can tell that, like, in general, like, the original PCs would have performed a little bit better at the same clock speeds, but whether it's because of optimizations or because of rewriting a lot of the stuff in assembler was actually effective, it's to be seen. Or a lot more of this stuff. As noted, my Doom port here, it rewrites some amount of the inner loops in assembler, but not quite to the same extent as apparently the 386 version. But partly it's because I'm not that inclined to rewrite stuff in assembler unless it seems to be fairly necessary, but it's a trade-off. Actually, my original hope, was that I had hoped this stuff would be fast enough to where I wouldn't need to have rewritten anything in assembler in these engines, but I eventually gave in because performance was being kind of crappy. So Doom, there appears to have been averaging through my course of fiddling at around 18 frames per second, which is pretty reasonable. Okay, see how much of this stuff in the top 10 is assembler. So this loop is assembler. This one is also as well, and likewise. Okay, yeah, and now past those top loops, we're getting into the stuff that's, off in C land again. So draw column, I think the outer part of draw column is actually it's actually still C. So sort of took a compromise approach of rather than rewriting a lot of the entire functions in assembler in some of these cases, just sort of leaving the top or outer parts as C and then writing the inner loops in assembler. But maybe actually, yeah, I think this one's actually assembler. So another assembler function, and yep, more epilogue sequences. So slight changes rather than a lot of time doing basically, or instead of just popping the link register and then doing a normal RTS instruction. In this case, it's reloading the link register into a scratch register and then just jumping to or branching to the scratch register. So that's a slight change as well. And also it does a few additional stack adjustments because since it's not using push or pop, it no longer automatically adjusts the stack pointer, so it's necessary to either at the beginning or at the end to adjust the stack pointer. And here's a prologue, which, as can be noted, works under a similar process, just in reverse. Namely, it adjusts the stack pointer, and then it saves off the registers using move instructions, and then it does actually return because the compiler tends to reuse prologues and epilogues between functions, because that saves a reasonable amount of space, or that saves a reasonable amount of space would otherwise be spent just saving and restoring registers. And if the later functions basically save or restore the same set of registers, it results in a case of may as well save them, or may as well reuse them. So I think this I'm pretty sure that function's still C, and fixed mole, this function, I'm pretty sure that's C as well. Noting that the first things it does is copies the arguments from one register to another register, and then proceeds to immediately save that other register to the stack. Yeah, that's pretty obviously compiler output. Because by handwrite assembler, it's at least a little more clever than that. So yeah, but yeah, if I really wanted, I could probably go and rewrite a little bit more of this stuff in assembler, but it works. And Doom at least performs a bit better than Quake does on this, so it's an improvement. Performance for Rise of the Triad has been still giving me issues, in addition to its crashiness. So, as can be observed after a few moments, Rise of the Triad also drops to a lower quality rendering setting, which is kind of what I was attempting to do with my Quake port there, but I went a little bit more extreme in the attempt to get frame rates or get usable frame rates, but may still fine tune it a bit because yeah. For context in this game, despite the guys looking like they're begging and stuff, you can't actually release them or anything. They'll just like beg for a moment, then fake die, and then pop up a moment later to continue shooting. So yeah, can't really actually let them go free or anything. In the case of this game, there has been a slight observed difference between the emulator version and the FPGA version. In the emulator seems to simulate it with slightly higher performance than the FPGA version does. So that's a discrepancy I haven't fully resolved yet. So yeah, in the rock case, yeah, it's mostly just a discrepancy in the case of, this is actually faster than I'm seeing otherwise. Also, can note that I noted before that this game has sound design that does come off a little bit like a PowerPoint presentation or something, but yeah. And it didn't work this time. And I'm stuck, so no clip time. Yeah. So yeah, rot is rot is rot, but not that much new. Not that much new with this, really. But that was averaging roughly about 12 frames per second, which is a little bit optimistic, but other than that, yeah. So this is a draw column function, which is that one was rewritten in assembler. This is a sound. So this is part of the sound mixing, which was still in C. This was the this is a function that mostly still exists because RAW is using a 256 color renderer, so it's kind of going and repacking the 8-bit pixels to 16-bit pixels after the fact, which is not exactly a super small part of the CPU time, so that's a factor in this case. Yeah, this function was rewritten in assembler, but can't really do that much for it though to make it fast because it has a lot of memory loads, so and it kind of can't really sidestep them because that's how it gets the palette colors. So C function there. Part of the intermixing loop, which was ASM, more C code, more ASM. So yeah, good mix here. And it's using the updated epilogue, so means I rebuilt it recently. Also integratified. Integratified is fun, and seems to be a non-zero part of ROT's total runtime cost as well. So, and another function related to integratified. Technically there is actually an instruction for this in the ISA, but I'd left it as an optional feature, and it's not being used in this case. But it was also kind of expensive, so kind of an expensive instruction, so I didn't really want to promote it to the core ISA just yet. May or may not be a surprise, but checking a 64-bit or 32 or 64-bit values and figuring out how many zeros are on the front of it isn't exactly a free operation. But the floating point unit does it, which is another possible implementation to see if maybe I could reuse the reuse the integer conversion logic as the CLZ instruction or something. but not done so yet. And of course, long multiply also makes an appearance, which is another one of those functions that has to be emulated because there's no actual instruction for that. Though looking at it, I do have some instructions now that could allow writing this a little bit more efficiently, because this reflects basically an earlier incarnation of the instruction set. But as noted, it's also entirely 16-bit operations as well, so part of it. But yeah, in terms of new shiny instructions, yeah, not that many have been added as of late. I think the last major additions were mostly the 128-bit loads and stores, and also also the simmed operations, which I think I actually talked about some of that last time. So yeah, slowly but surely this instruction set is gradually starting to stabilize. Ongoing simulation, or just sort of running Doom, but shows basically the memory access patterns. So first two lights basically mean it's whenever it's stalling, waiting for something, and these ones tell what it is. So first one basically means memory of some sort, and then this will basically say which memory or part of the memory subsystem is stalling. But most of the activity seems to be being from the data cache, so it's kind of the general pattern it's been for a while. Other possible things that could have been causing delays could have been things like interlocks, but as noted, interlocks don't really seem to be that big of an issue for the most part. It's mostly seems to be concentrated along the lines of memory access. Something has changed this time. It is failed timing somewhere. Granted, these sort of random timing failings are kind of something that happens sometimes, but in this case it may or may not reveal something relevant. Okay, so a signal has failed somewhere. Failed somewhere within the L2 cache, it looks like. May or may not have something to do with it being routed pretty much entirely across the FPGA. Which is, well, something that can happen when you're using pretty much the whole thing. Oh yeah, that's a event that's supposed to take 10 nanoseconds, but it doesn't, or it takes over 10 or more than 10 nanoseconds. So an endpoint fails. And again, that's not exactly a surprise because, you know, it is, well, using pretty much the entire FPGA right now, and also the cache, or L2 cache, is pretty big. I don't necessarily know if I'll keep the settings at these higher cache sizes, but And it looks like stuff has apparently gone into some sort of limbo state again. OBS says I'm still uploading, so yeah, but yeah. Yeah, using pretty much the whole FPGA here, so yeah, I don't know if I'll keep the bigger cache sizes or if I'll reduce them back down to where they were before, because as noted, about the only thing I really actually noticed a difference in terms of frame rates on was Doom, and also Doom doesn't really need that much right now. Could have been better if it helped with Raw or with Quake, but again, they're not faring as well. So, I guess some uncertainty was, cache hit and miss rate with Rot, but so it's, yeah. So yeah, still looking at Rot here, but this time or another, the hit rate isn't too bad. Yeah, in a past test, I was seeing considerably worse L2 hit rates, but in this case, yeah, it doesn't look like it's doing too badly. Seems to be pretty prone to vary though, and this is after adjusting the model for the larger caches, which could be a factor as well. I had looked at my old presentations, and not that much has changed long in terms of high level architecture, so my old slides should still be reasonably valid, apart from the recent addition of 128-bit operations and jumbo ops. But yeah. guess the open question here is if there's anything or any still obvious low-hanging fruit I can use to further improve performance, which I've been looking for, but annoyingly it seems that's easier said than done. Okay. All right. It appears it's not happy about something. Looks like probably the compiler has crashed for some reason. Which is curious because I haven't really changed that much since earlier. But yeah, just going to see if I can recreate it in the debugger and see if it tells me anything informative. Well, clearly that's not a valid pointer. Oh yeah. Sometimes mysterious stuff happens like this, like our compiler is crashing, which means compiler bug of some sort. Looks like it's in the front end somewhere, or front end or middle end. And I overshot it. Oh yeah. That looks obviously like a double precision value. Think for the value 1. Maybe. No, it's not 1. But, yeah. Looks like less than 1. Like 1/16. Something like that. But yeah. But what it's doing in my hash table, I don't know. But it does mean I have something to debug. Yeah, probably going to call it all for now, because we'll kind of need actual focus to debug compiler and yeah, trying to come up with stuff to talk about is admittedly a little bit distracting, and not that sure how many or how much anyone in the off chance they actually watch this would be that compelled in me sitting around trying to debug something in my compiler. But yeah, we'll say that this isn't usually the usual occurrence because my compiler is at least usually reasonably well debugged, so it doesn't really crash that often. But yeah, but I will go off and try to figure this one out. And hell, maybe it'll start generating better code or something as well, which would be nice. Yeah, probably won't though, because compilers are fun that way. But maybe at least it might be more deterministic, because that is one thing I've observed before. Is like sometimes on different builds of the thing with exactly the same input, it will give different results. Like the binary might be a little bit bigger or smaller, or other things like that, which indicates that there's probably something not quite right. Because ideally this stuff should be deterministic, so, but if there's non-determinism going on, all means that there's something is buggy, and it's something that's buggy that's affecting the behavior. So guess I'll get to this.